Hey everyone, I just wanted to quickly go over the first problem of the Check Your Understanding of Lesson 2.1 since we didn't get to go over that in class. So, this problem reads, select the values of a polynomial f are given. Determine the degree of the polynomial. So here is a table of values, and they're asking us to find the degree of whatever polynomial this table might represent. Okay, so what is a degree? Especially of a polynomial. Okay, let's think back to previous functions that we've done. Functions with degree of 1. Those are just linear functions, right? So you have x raised to the power of 1 plus 2, which is just x plus 2, right? And that is a linear function. Another linear function that we have is 2x plus 6, right? And that has a degree of 1. So if we go back to, let's see, if we go towards functions that have degree 2. Those are just quadratic functions. They look like this. Degree of a polynomial, here's the formal definition for it. It is the highest power x is raised to in a function. So we look back at degree 2 functions versus degree 1 functions, right? Degree 2 functions, we have x being raised to the second power being the highest degree, and x being raised to the first power as the highest degree for linear functions. For quadratic functions, it would be degree 2. Okay, so those are the degrees we've worked with in the past. We're just introducing more degrees. Way more degrees, right? So, what kind of strategies can we use with tables? Well, we know if these x values are the same, we don't have to find average rate of change since the x values are increasing equally, right? They're increasing at a constant rate on this table. Our outputs, I wonder if they increase by the same amount. Because if they increase by the same amount, that would give us our first difference being the same. If our first difference is the same for every equal increase in x, then we have the same slope for all of the points that are represented on this table. So if our first difference is the same, then our rate of changes are the same for all given values. So let's check it. Pause the video to do the calculations. If you don't know how to do the calculations, I'll go through them right now. So from 45 to 5, we subtract 40. From 5 to -3, we subtract 8. From -3 to 69, we add 72. From 69 to 653, we add 584. And from 653 to 2,565, we add 1,912. Okay. So that's our first difference, and we see that's not the same. So this can't possibly be a linear function, okay? So for our first difference, we're checking to see if the function is in the first degree, and it's not, okay? So let's see for our second difference. All right, we've used this in tables before. So second difference, we have that 40 to negative 8 is add 32. Negative 8 to 32, we add 80. And then we add 512 here, and we add 1328 here, okay? And that's our second difference, right? Because 912 minus 584 is 1328, and so on and so forth. So, yeah, our second difference, not quite the same, but if we remember what our second difference represents, it means that our rate of change actually increases at a constant rate if they're all the same. But it's not all the same. Let me just write that down here. So this represents the change in rate of change, right? And it's not the same, okay? Now, what do you think we have to do next? It's something that we did in class today. We took the third difference to figure out if this is in degree 3, or yeah, the polynomial is degree 3. So we have 48 for this, yes, okay, 432, and 816, right? Same kind of calculation. We do 1328 minus 1512 to get 816, 1512 minus 80 to get 432, and then 80 minus 32 to get 48. And then that is our, guess what, third difference. It is not all the same, these differences, so the function is not degree 3. Okay, what do you think we do next? We keep pushing forward, okay? Keep pushing forward like we always do. 816 minus 432, that's 384. And 432 minus 48, that's also 384. Aha! So these are all the same. And this is our fourth difference. So that means that this function has to have a degree of 4. This function has to have a degree of 4 because the fourth difference is the same. So using what we know from linear functions and quadratic functions, we can actually expand this pattern, right, to cubic functions like we did in class today. And then now we have a fourth difference being the same, and that just means our function has a degree of 4.